Michal Holcapek. So the first speaker is Michal Holcapek from University of Pardubice. I hope I said that correct. Otherwise, again, I apologize for that. From the Czech Republic. I'm not sure there's anything that I can say about Michael that adds anything to what all of us know about his lipids. The funny part about this is that I spent a lot of time working on many different fields of lipid analysis, and name always showed up. Starting from oil analysis, olive oil analysis, to biomarker discovery. So I'm mute, I don't know why. Can you hear me now? I think I'm stupid. I don't know why, but all of a sudden my PC muted. So I was introducing Michael. So there's very little to say about him and the contribution that he made to the world of lipids. From basically, there's no field of lipid biology and lipid analysis in which he didn't give any substantial contribution. And I believe that now he's very much involved in lipids as biomarkers, and I guess he will talk about this in his speech. So now I leave the stage to Michal. So please, you can start sharing your screen. Thank you very much again.
Thank you very much for kind introduction. It's really a great opportunity for me to come here to this online symposium and to present our quantitation approaches, what we have developed with my group within the last couple of years. So my lecture will be focused on the right lipidomic quantitation based on lipid class separation. And finally, I will present some our data in early cancer detection. So I expect that you all know well this lipid classification system according to lipid maps with 8 lipid categories and numerous classes and subclasses. Mostly we just focus on the 5 most common lipid categories: fatty acyls, glycerolipids, sphingolipids, sterols, and glycerophospholipids, because other 3 categories are less common and they typically require dedicated methodologies. So I'm starting with the workflow of lipidomic quantitation, which is also nothing surprising that we start from the sample collection, typically biological fluids or tissues, then the addition of suitable exogenous internal standards, sample preparation, typically liquid-liquid extraction based on chloroform, which is preferred in my laboratory. Then the key part is mass spectrometric analysis, either using liquid chromatography or preferably supercritical fluid chromatography or shotgun approaches or use desorption ionization techniques. Then very difficult and time-demanding part is data processing. We are using our own software, which is freely available, called LipidQuant. And finally, the statistical evaluation using advanced tools of multivariate data analysis. So first, I would like to explain 2 major strategies connected to chromatography, called either lipid class or lipid species separation approaches. So first one is called lipid class separation. It may be either HELIC, SFC, or eventually normal phase chromatography. And here the advantage is that your internal standard will collude with all analytes from the same lipid class. So it simplifies very significantly the lipidomic quantitation and also automation of your data processing. But there is also a drawback that you report just the summary formula with the total number of carbons and number of double bonds. If we go for lipid species separation, mainly reverse phase chromatography, here the advantage is obvious that you have much higher separation power. You can resolve isomers, which results in about 2 to 3 times more detected species. But here the quantitation is much more demanding. I don't say impossible, but you have to be very careful with multiple internal standards per class, not only one. And ID is also more difficult, that you may need some advanced tools for identification. Just to explain further these two approaches, I use these simple schematics. Here you see, for example, a silica gel column with 3 silanol groups, and these polar groups will interact with polar functional moieties in phospholipid and sphingolipids, and then the effect of these acyl chains is very small. So the result is shown here, that you will just separate the lipid classes, and then the separation of species according to fatty acyl chain lengths will be just very small within this overall peak. In case of reverse phase chromatography, lipid species separation, then the mechanism is different. The stationary phase is nonpolar, for example, C18, and these nonpolar chains will interact with nonpolar fatty acyl chains, but also polar heads influence the separation. So finally, we will separate all of them. Here are just few examples of results for individual modes. I'm starting with the helichromatography. So you may see here that within 10 minutes or even less, using sub-2 micron columns, you may separate many phospholipid and sphingolipid classes pretty well with nice peak shapes. But unfortunately, non-polar lipid classes like tri, di, and monoacylglycerols, cholesterol esters, and some ionic lipid classes like sulfatides will collude in the void volume of the system. So you may have difficulties with their quantitation. But if you switch from helic mode to ultra-high performance supercritical fluid chromatography, then you see really smart separation also for all these non-polar lipid classes together with polar lipid classes using this supercritical or subcritical carbon dioxide with modifier. These papers were already published, so you may see here that within 6 minutes we can separate 30 or even more lipid classes and use it for quantitation. If I show you the most recent methods what we are using now for routine quantitation, you may see for samples of human plasma that we are here like within 4.5 minutes. So the total cycle time is within 5 minutes per sample. So it's really high throughput and fully automated quantitation. In case of helic, it's only slightly longer, below 7 minutes. In case of lipid species separation, which is shown here from our recent work, we need something like 24 minutes for really nice separation of various isomers. So we can report here over 500 unambiguously identified lipid species, but we don't have lipid class separation and we have more difficulties with quantitation. So you may choose depending on your application. So the first step when we talk about the quantitation is the choice of right internal standards. So it must be at minimum one internal standard for each lipid class to be quantified, but better to use more. It must be added before any sample preparation, and if possible, collude with analytes. It means lipid class separation. And here you see the list what we have developed within the last couple of years for these 5 categories. So mostly we use deuterated internal standards highlighted in red, or in some cases shorter fatty acyls because they are cheaper, but you need to verify that they are absent in your samples. In some cases, we use even longer fatty acyls or odd carbon fatty acyl chains. The reason why I don't like too much the pre-mixtures of internal standards provided, for example, by Avanti, is that you really need to tailor perfectly the concentrations of internal standards. Here you see 2 cases where the concentration of internal standard in comparison to other species within the class may be too low, or in this case is too high. We try to keep this concentration somewhere within 1/3 to 2/3 of the intensity of the most abundant lipid species within the class to have the most reliable quantitation. And for this reason, we prepare these mixtures by ourselves, then we aliquot them and use it over the whole year for quantitation within my group, which is, by the way, also slightly cheaper compared to these pre-mixed internal standards in splash mix. Another important step, extremely time demanding and boring, is the method validation. We have implemented these recommendations from FDA and EMA and developed the protocol how to validate all new methods for the quantitation. Here, I'm not going to explain anything concerning these individual items because this was already published and because it would take more than 1 hour to explain everything. But just trust me, if you do all these things, then you are absolutely confident that you don't have any bias in your methodology and you may use it for high throughput quantitation. It happened to us a couple of times that we have detected unexpected problem for some internal standard or for some lipid class, and then we have repaired and modified the methodology. Here you see some pre-analytical aspects. I'm starting with the stability of lipidome over 1 year. So we have selected 99 healthy volunteers and collected the blood at the time 0, then after half of a year and after 1 year. And you may see here residual standard deviations labeled by different colors. So for non-polar glycerolipids, tri, di, and monacylglycerols, you see many red colors. It means pretty high variation, which is probably caused by different nutrition over the year. But for polar lipid classes, the variation is much lower, which means that these classes are much more convenient for biomarker discovery. So you may see that in many cases, it's below 10 or below 20% over the year. So the lipidome for these classes is relatively stable. And of course, for quality control samples, the variation is below 10%, which is relatively good. There is quite often question whether to use plasma or serum. We have compared for all these samples, both sample types, and you see quite perfect fit. But the only difference is that serum concentrations are about 20% higher, but the composition for all studied classes is more or less identical. So it does not matter what you use, but don't mix it. Quality control for all studies, we prepare first so-called pooled sample. It means that we mixed all healthy and all disease samples, or for large studies, a certain portion of them, to prepare so-called pool sample, which is then regularly injected after 20, 30, or 40 samples. And you see here in this principal component analysis graph that all these points should be in one area as a proof that you do your analysis reproducibly. If you monitor individual concentrations in one-dimensional PCA graph, then you see individual colored points are at the same position, which means that your methodology really works well. Now, one slide with normalization. This is something what I don't like too much because various types of normalization may hide problems in your methodology. So if you use it, just do it with care and be sure that you don't introduce anything artificial. My colleague decided to measure the identical samples, like 300 samples, on 4 different platforms. It means one SFC connected to 2 different QTOFs from the same company, and then the helix system connected again to these 2 mass spectrometers. All extracts were measured in the same time period, so you would expect that everything should be identical. But this is the result, that this is definitely not so great as you wish. And also for quality control samples, you don't see perfect match. What to do with this? For this purpose, we have also measured NIST SRM plasma samples, and then used the normalization to these concentrations, and after this, you see quite perfect match. So in these individual circles, you see number of patients measured by 4 different techniques, and here you may see that data are really very correlated. It would be really great if you can do it without normalization, but at this moment, simply we are not capable to do it, and I guess that no one else tried this so far, but I hope that in the future we may do the same without normalization. But for this purpose, we would need internal standard for every single molecule, but this is probably out of technical possibilities at the moment. Now I would like to show some data for our cancer research. So here you may see our most successful study of pancreatic cancer, which was divided into 3 different phases called discovery, qualification, and verification. So we have started here with this number of samples measured just in my laboratory. It means laboratory number 1, using 3 approaches: SFC, MALDI, and shotgun. In phase 2, we have invited colleagues from Germany and Singapore, and they used additional 3 methodologies. And finally, the verification phase for more than 400 different samples obtained from 4 different Czech hospitals. So everything in red further will relate to pancreatic cancer patients. Blue is healthy controls, and green color means chronic non-cancer disease called pancreatitis. So I start with the discovery phase for these 364 samples. So first, non-supervised PCA statistics. So you see that quality controls are in one position, but the separation of healthy and cancer patients is only very, very slight. I would say almost nothing. For supervised analysis, you see quite perfect separation with the labeling of individual cancer stages by different color tone. Okay, measurement by second methodology, by shotgun approach. Here, even in non-supervised principal component analysis graph, you see already partial separation, which is quite good to make sure that your division in supervised OP-LSDA is not artificial. And here you see quite perfect match, almost 100% success with quite a big gap in between. So evidently, we have realized the potential of these measurements, and we have patented this methodology and also prepared a paper based on these measurements. For the phase 2, we have invited colleagues Gerhard Liebisch from Germany, Markus Wenck from Singapore, and they added these 2 shotgun approaches with high and low resolution in Germany and reverse phase chromatography in Singapore. And we used over 500 samples. Here you may see again the similar results obtained by individual laboratories, including sensitivities, specificities, and accuracies, both for training set, it means known classification to analytical chemists, and validation set, it means that the classification was not disclosed to analytical chemists before reporting the results. So this is the real situation to verify that the method is really useful for unknown samples. So you see always this annotation, either training or validation. And in case of validation, these numbers are always lower, but not so much. So the model is really robust. And here, just quickly, I will show the results measured by other laboratory using shotgun approach. So I just show one example for males using triple quad analyzer and for males using Orbitrap analyzer. So again, the resolution is quite good. And the last data set measured by reverse phase chromatography, it means lipid species separation. Here you may see even better group resolution than in previous cases. But the key slide is shown here. Here you may see the comparison of absolute molar concentrations for most dysregulated lipids observed in this study. It means these sphingomyelin with very long chain and one double bond, the corresponding ceramide, and also lysophosphatidylcholine 18-2, but I may show the same results for many other lipids. And here you see that in blue, healthy, in red, cancer patients, but quite good fit among individual laboratories. So here you see 4 different laboratories, and the variations are relatively small. I should also add one information that these graphs were prepared after normalization. If we do it without normalization, then we have relatively good fit among all lipid class approaches, but we have a certain discrepancy with lipid species separation, which shows that these lipid class approaches are really stronger for the quantitation. And I highly consider you to consider either HELIC, SFC, or shotgun for robust quantitation. Below you may see ROC curves for individual approaches separated for training sets and validation sets, and with one exception, all values are above 0.9, which is pretty encouraging. The question of one of reviewer in Nature Communications was whether we can really prove the claim that it works well for early stages as well. So you may see that we don't have so many samples for pancreatic cancer with stage 1 or stage 2, but we have prepared these separate box plots. So the lighter red color shows early stages, and darker red or brown means later stages, and you see almost no difference, which is really excellent, and it confirms that our accuracies for early stages are the same as for later stages, which was something which was really questioned by one reviewer, but finally accepted that we have data for such claim. And in green, you see pancreatitis. So we don't have so many samples, we need to do more, but we are able to differentiate even this disease from malignant cancer disease, which is also very important. So far, I have showed you just the data for pancreatic cancer, but we have the data sets for at least 3 additional cancer types. Here you see the results for kidney cancer. We have also measured prostate and breast cancers and some others. Here results are slightly worse than for pancreatic cancer, but with most cases, we are over 90% of resolution, both for females and for males. Results for males are typically slightly better than for females, because in case of females, you have other factors like hormone cycle, antiperception, and so on, which may slightly complicate the situation about the lipidomic quantitation, but in general, it's not so bad. For the data processing of all the data showed today, we used our own software called LipidQuant 1.0, which is a pretty automated tool for processing of all lipid class separation approaches based on high resolution. This is basically the script in Excel. This is freely available on my website, or here it's already accepted in bioinformatics and should be published this week. You have very detailed guide how to use it with README file and everything. So I'm not going to tell you any details on this. If you are interested, you may download it and use it, or consult with us, or modify the software as you wish. Everything is possible depending on the license what we have given to this software. 2 important things which are implemented in the software are isotopic corrections. There are 2 types of isotopic corrections. First is called type 2 correction, which means that if you have the lipid class mass spectrum, you always start with the interpretation from the left. So if I start here with this PC, and then I may calculate theoretically M+2 contribution. And this M+2 contribution for this lipid will contribute to this lipid having 1 double bond less. So you need to subtract this theoretical value from this intensity just to correct this systematic error. And then when you do it, then you calculate M+2 contribution for this lipid and subtract this value from the lipid having another double bond less. And this way you do the perfect quantitation. If you don't do it, then you have a relatively large systematic error. And in some cases, the error may be up to 100%. So this is also implemented in our software. And the second feature, isotopic correction type 1, is explained here from this paper of Jiankling Han, that if you prepare equimolar mixture of all standards, then for higher masses, you have higher contribution of M+1 and M+2, which results in the fact that the intensity of M will decrease. it follows this pattern. So after this correction factor, it will be again equimolar and identical as it should be. So without this correction, you again report incorrect concentrations. So both of these features are implemented. So finally, because my time is gone, I would like to acknowledge the support of grant projects of all my co-workers and numerous clinical cooperators. By the way, you may see that 2 members of my group are from Italy. So if you are interested in the work in my group, don't hesitate and write me a letter. So we welcome any people who are really motivated to work with mass spectrometry and lipidomics. And we have quite good equipment, so you may enjoy and learn something new. Finally, I would like just to announce the conference organized by International Lipidomics Society, what you may know probably well about the activities of this society. And this conference should be organized in Regensburg this October, and we have both on-site and online format. So if you are interested, definitely check the website and join to us. Thank you very much for your attention, and I am ready to answer any questions.
Thank you, Michael. And I think that you showed how powerful lipidomics is in biomarker discovery. Now, is there any question for Michael from the audience? Because I've got like 10 to 20 questions for you. I think you guys can raise your hand and unmute yourself if needed. Okay, then if there's no question, I would make a couple of questions. The very first is very, very technical. At the beginning, you showed how complementary direct phase chromatography, like Illich, for example, and reverse phase chromatography are. I was wondering if you ever played around with 2D chromatography using these 2 phases, like, first dimension with Illich and the second reverse phase. I fixed that because we did something in our lab in the past, but we never really came up with something robust.
Yes, we have published a couple of papers on this. So we have published papers on offline coupling of Illich and reverse phase, online coupling, and at the moment we are working on online coupling of LC and SFC. So this is of course possible, but honestly, I'm not a big fan of 2-dimensional approaches for simple reason. If you use it offline, then you may do very detailed identification, but it's laborious, it's time consuming. If you do it online, then you have dilution in 2 dimensions, and it means that you will identify and quantify much less lipids. I would say about 1/3. Yeah. And it's really difference whether you quantify 400 lipids or 150. Yeah. So for this reason, and these limitations are, I would say, fundamental. So it's impossible to avoid them completely. You may reduce this dilution effect according to the approaches introduced by Peter Schoonmaker's group, but you cannot rid of them completely. So with 2D, you will always report less lipids compared to 1D. So this may not be evident to everyone, but for this reason, I'm not the biggest fan of 2D, regardless of the fact that we do it and that we publish it. Okay,
okay. And the second question is about your software that came out. I think I got a Twitter message about this new software. Can your software work with, for example, I think you mentioned it, with the splash mix from Avanti, or is it dedicated to your own internal standard mixture?
With any internal standards, it does not matter. You simply set it, so it does not matter. So any internal standard will work, but you need to use at least one internal standard per class. You set the concentration and then it works. Okay. It's easy.
I think we will look into it. Any other question from the audience? Otherwise, we move to the next speaker.